Hello and welcome to NASA Today, Tuesday, May 19th, 1992. I'm Catherine Greenfield. Now that Endeavour is back home, computer scientists and engineers are focusing their attention on an experiment which incorporated a cutting-edge computer technology on board the orbiter. Fuzzy Logic computer software was used to run a thermal control system in an experimental unit within the payload bay. It kept temperature fluctuations to within 1/10 of a degree. Past thermal control systems using conventional computing have only been able to keep temperature fluctuations to within 1/2 degree. Fuzzy Logic was the topic of a recent NASA Goddard conference at which hundreds from the worldwide artificial intelligence community attended. Dr. Lotfi Zadeh from the University of California was the keynote speaker. He pioneered fuzzy logic computing 30 years ago, but not until now has it begun to catch on. Fuzzy logic, he says, uses approximate reasoning and common sense thinking to perform tasks.
You take a sort of more opportunistic point of view. You say, I want a solution, it may be approximate, I may not be completely sure that it is true, but that's good enough for me. It works. It's a sort of more pragmatic type of approach.
NASA is beginning to incorporate fuzzy logic computing in many of its remote control systems, such as docking the shuttle to the space station or operating the Mars rover in a way that helps it avoid collisions or getting stuck in holes. Fuzzy logic also may soon be utilized to tether satellites.
It's much like, I guess, if you were reeling in a fish through the water, for instance. If he moves this way or that way, it can make a big difference in how he comes in. So what you need that tether to do is to come in as you'd ideally like it to come straight in, okay? But what it's realistically going to do is it's going to move around and it may wobble this way. And so what you want to do is to control those wobblings. You want to try to keep them as smooth as you can so that you don't get the situation where the tether maybe wraps around the shuttle and they have to cut it loose and let it go because it's too dangerous.
Although the fuzzy logic-based tethered control system outperforms the current system, its development came too late to be used on the upcoming STS-46 tethered satellite mission, scheduled for launch in July. EUVE will launch in June. Previously scheduled for late this month, liftoff has been moved ahead due to the delayed shuttle launch of STS-49. Preparations now continue for launch on the 4th of the month. The first and second stages of the solid booster have been installed, building EUVE's Delta rocket. An interstage was placed between the two stages, and 9 solid rocket boosters were placed around the base to comprise the launch vehicle. EUVE's high-gain antenna was also installed. This will receive and transmit radio communications and will be steered to communicate with a TDRS satellite high above in a geostationary orbit. EUVE will examine the least studied portion of the electromagnetic spectrum, making both spectroscopic and wideband observations over the entire extreme ultraviolet region of the sky for 18 months. It was a meeting of the minds, at least the Galileo spacecraft minds. The group gathered earlier this month to determine which tour Galileo would take after reaching Jupiter. A selection was made, and Tour 9214A made the cut. In simple terms, the group says this was the best compromise among those generated. It includes 4 non-targeted flybys, where the satellite will obtain global studies from distant satellites. It also will include flying through the tail petal of Jupiter's magnetosphere on the 9th orbit. Previously planned for the 11th orbit, it was feared Galileo would run out of propellant or funding and not be able to complete the end of the tour during which this experiment was planned. After its Jupiter encounter, Galileo will spend 23 months touring Jupiter's magnetosphere and satellites. Also decided by the group was Galileo's arrival date at Jupiter. It was proposed to have the spacecraft arrive 1 week earlier to save on propellant, but in doing so, it would have degraded the Io Taurus experiment. The date will stand as originally planned, and it was confirmed Galileo will fly by a second asteroid. On August 28, 1993, Galileo will fly by Ida. Planning is already underway, as this date leaves only 8 months between Galileo's second Earth flyby this December and the asteroid encounter. Imagine picking up the telephone to call a relative 3,000 miles away, and when the phone is answered, you not only reach out and talk to that special someone, but you see him as well. Or how about holding a business meeting with the attendees in 20 countries simultaneously? Sounds like something out of the year 2001? Well, thanks to NASA's state-of-the-art communications networking system, Internet, this world is just around the corner.
The Internet is a system of electronic roads, highways, and superhighways that allow people to talk to people via their computers. And this allows a number of tasks to be performed for science as well as for education and research in general. We feel that the possibilities created by the Internet is really unlimited by technology. It's limited only by the imagination of the people who are using it.
That imagination so far has brought a system initially designed for the Department of Defense to allow for communication between command posts to relaying questions from third world country doctors to modern professionals during epidemics, earthquakes, and other natural disasters. Today, its most common use is with NASA's science community. Services range from sending electronic mail to colleagues halfway around the world to contributing to the success of the missions in space.
If you're an investigator on Galileo, you'll see that the data is returned to you in near real time. I mean, within seconds of its landing and, packaging at the Jet Propulsion Laboratory, we then disperse that information throughout the world to the scientists so that they can have that information readily available. And the hope is that then they can take that information, if they need to have corrections or information changes and updates to the instrument packages on board those spacecraft, that they will then look at the data, do hopefully a quick look or a browse against that data, and then return, say, well, actually I need to take this pass at the Earth, or I need to take a different kind of pass at Jupiter, and on the next pass around, can you readjust my instruments such that I'm going to look at this, have this look angle, as opposed to the last one.
The range of the system is just as impressive, reaching areas of the world that never before had science networking services. Internet's newest venture has been to the Antarctic. Its most ambitious assignment is to provide researchers at Ames with near real-time data from studies in the depths of Antarctic's permanently ice-covered lakes. The results are expected to give insight to the environment we hope to find on Mars. The uses of Internet are limitless, and plans for expansion are unstoppable.
I can imagine, for example, in not too distant future, the ability to do video teleconferencing over the Internet. And you realize what this means. It means that for those who have a personal computer in their home, they can look into the computer and essentially dial up a relative across the country and have their children sit at the screen and talk to grandma and grandpa, and this is a wonderful thing for establishing better communications between people.
Not only could family and friends hold these video phone calls, but business plans could be passed through the TV screen from one country to another. Students could receive instruction from teachers at schools with larger curricula, and scientists could collaborate on projects without traveling to each other's laboratories. Perhaps most importantly, this development would obviously give the U.S. technological leadership in the telecommunications industry. And for that alone, there is no question as to the value of this electronic highway.
NASA thinks it may have found the equation for success in making the younger generation more math literate. For the past 9 years, the space agency has co-sponsored a nationwide competition called Math Counts. Very similar to the National Spelling Bee, hundreds of thousands of 7th and 8th grade students compete throughout the year on state and local levels in an effort to win a trip to Washington, D.C. as the top American mathletes. The final day of competition was held last Friday. Each state sent a team of its 4 best mathletes to vie for the top 10 spots. This year's top state team came from California, the only team ever to win the honor twice. But the brain power increased exponentially as the top 10 individual mathletes went head-to-head.
33,150. I'm sorry, that's incorrect. All right, Robert.
3,075.
That is correct. So, Robert takes this round. You score,
It came down to Andre Gnep from Orange, Ohio, and Jennifer Hoffman from Greenwich, Connecticut. Andre had the answer often before the question was even asked.
4/25.
That is correct. And
As the first place medal was slipped over his neck, Andre seemed to take it all in stride. Afterwards, I asked him which questions were the hardest.
I don't think that many of them were so hard. Most of the mistakes.
Andre comes by his math prowess naturally. His mother is a math professor, and his dad is a computer scientist. And guess where? NASA's Lewis Research Center. Stephen Gnep is a computer scientist in the aeronautics division, but he has no plans to push his son into the field.
There are so many new fields opening up and new areas. In biology, the effort to map the human gene system. In physics, they're just starting to find out uneven, non-uniform distribution of the universe at the moments of the Big Bang. They're guessing they just caught a glimpse of it with COBE. There's so many fields that new things are coming out in, and in another 10 years when he graduates, there may be things that haven't even been discovered yet. And I think it's a mistake to channel a person at this age into a particular area.
As the first place winner of this year's Math Counts, Andre gets an all-expense-paid trip to NASA's Space Camp in Huntsville, Alabama. By the way, one of the brain twisters asked involved the shuttle. So put on your thinking caps, get out your pencil and paper, and see if you can figure this one out. After the space shuttle's solid rocket boosters have taken the shuttle to an altitude of 28 miles, they are jettisoned, at which point the giant external tank begins feeding liquid hydrogen fuel and oxidizer to the three main engines. Given the capacity of the external tank is 526,000 gallons, and its entire supply is exhausted in 8.2 minutes, find the number of gallons each engine consumes per second. Round your answer to the nearest gallon per second. In the time it took to read this question, most mathletes would have gotten the answer. And here it is. Are you ready? 356 gallons per second. And that's our news for NASA Today, Tuesday, May 19th, 1992. Thanks for joining us, and we'll see you tomorrow on NASA Today.